In learning objective A, we're going to talk about how to algebraically find the zeros of a function. This can be done with either roots, factoring, or the quadratic formula. Okay, before we dive into the quadratic models, let's just revisit what a linear model is again. It models situations that have a constant rate of change. And the constant rate of change on a linear model is actually found within its slope. Okay. Now, we've looked at exponential models. What those do is they model situations having a constant percent change. And that constant percent change, when we look at the format of an exponential, is actually the growth or decay factor, or the b value. Now, quadratic models are of the format, again, that we see up here, ax squared plus bx plus c. When you graph them, they have a parabolic shape. Now, in those parabolas, there's two key things you're going to see. You're going to see a minimum point or a maximum point. So quadratic models, they are models that have situations that have a max or a min to them. Now, I'm not sure if you remember, you are able to tell if a parabola is actually going to open upward, as this one does, versus downward. It's actually going to be based on the a value, or the number that's in front of the x squared. Remember, if a is greater than 0, the parabola will actually open upward. For downward, a is going to be less than 0. The other thing is when we have the quadratic formula, we actually will see what's called the discriminant inside of it. So b squared minus 4ac. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What you learned in Algebra 2x is when that discriminant, or the b squared minus 4ac, when it is greater than 0, you are actually going to have two answers, and they're going to show up here on the x-intercepts. Now, on the graph over here to the right, we don't see any x-intercepts, which means the parabola doesn't cross there. And what we learned last year, that means the discriminant is actually less than 0. That is, the number that's inside of the square root is actually going to be a negative number. When that's negative, we are not going to see any real x-intercepts show up. Now, in terms of domain and range, the domain means what x can be. And again, if you don't see any breaks in the graph where you had to lift your pencil up, there's no domain issues. The domain for both of these parabolas is all real numbers. The range is going to be slightly different. The range is the y values. When we look down here in this y region on the graph, there's no activity. The y activity does not start until we reach the vertex and everything above. Because of that, the range is going to be limited. The range is just going to be anything, or the y values from the vertex on up. You know, when we look at the parabola over here that points downward, that's just going to be backwards. There's no y activity in this positive y spot, but when you get below the vertex, we have graph activity. So for this one, the range is going to be all the values at and including the vertex. Now let's just look at letter A here. They want us to consider the function 2x squared minus 3x minus 2 and find the x and y intercepts of the graph. Well, let me show you a quick sketch of the graph. Here's what the parabola somewhat looks like. So they're going to ask us to find the x-intercepts and the y-intercepts and do it algebraically. So if we look at this graph, we actually see two real x-intercepts, and we can find them either doing the quadratic formula or factoring. So to do that, I'm going to try to actually factor this first. If you're good at your factoring, remember, here's how it works. I need to take 2x squared, which is the first of the trinomial, and make it the first of the two binomials. You need to break it up evenly. The only way to break up an x squared evenly is to give each side an x and an x. Now you need to think of factors of positive 2. Well, that's 2 and 1. So 2x times 1x is the 2x squared we see here. Okay. The next step says find factors of -2, which is the last part of the trinomial, so it goes on the last part of each binomial. Well, the factors of -2 are either -2 and 1 or 2 and -1. Now you have to put them in the right place such that when you do your FOILing or you check the two middle terms, it comes back to -3x. And here's what I mean. If you multiply these two and multiply these two and add them up, it should equal -3x. So I'm going to try the factors of -2 and +1. I'm going to put +1 here and -2 here. Let me show you. 1 times 1x is 1x. 2x times -2 is -4x. That adds to -3x, which is my middle term. So that actually does work. Now, those are the factors. So to find the x-intercepts, or what we call the zeros, you set it equal to 0. So I'm going to take each of these two factors, set them equal to 0. The first one would say it's this equal to 0. The second one is x minus 2 equal to 0. Clearly, to solve this one, x is equal to 2. To solve this second one, you would subtract 1 from both sides. Then you would divide by 2. So x would be -1/2. So the two x-intercepts we're seeing in the graph are -1/2 and 2. Now, let's say you aren't that strong of a factorer and you wanted to be able to do this with a quadratic formula. You could do that, and let's take a peek. The quadratic formula says interpret a, b, and c. So a is in front of x squared, so it's 2. B is in front of x, it's -3. C is the value by itself, -2. We're going to actually use the quadratic formula, which says x equals -b plus or minus the square root of b squared minus 4, then a and c, all over 2 times a. If we simplify this, we're going to get a +3 plus or minus the square root of 9. -2 and 2 is -4. -4 is +16. On the bottom we have a 4. This is equal to 3 plus or minus the square root of 25 over 4. That breaks out here then to 3 plus or minus 5 over 4. Now remember, we're going to break this off into its two answers, one with a plus and one with a minus. So it's 3 plus 5 divided by 4, 3 minus 5, all divided by 4. You must do 3 plus 5 first, which is 8, divided by 4 is 2. 3 minus 5 is -2, divided by 4, which simplifies to -1/2. So either way, you're going to get the same answer. The last thing they want us to do is to find the y-intercept. Well, the y-intercept is right here where it crosses the y-axis. Now, the y-axis, it looks like this is the ordered pair 0, 2. So what you should notice about the y-intercept is it happens when x is equal to 0. So to find the y-intercept, what you do is you set x equal to 0 and solve. Well, this one's nice and easy to find. I'm just going to do this. We're going to set x equal to 0, so we're going to put 2 times 0 squared minus 3 times 0 minus 2. This actually simplifies to -2, and we get the final answer. Now, one of the things I should have highlighted about the x-intercepts is, again, take a look at these. We found these x-intercepts. The one thing they have in common is there's some number in 0, and this other one is some number in 0. So if you need to mathematically find the x-intercept, what you do for the x-intercept is you set y equal to 0 and solve. So when we set y equal to 0, what we actually did is we went back up here and we made this value here 0, which then allowed us to factor or use the quadratic formula and solve.